Well, welcome back. This is Sung from Sky Academy, and I want to give you an episode, as promised, on what we're going to call it concurrent lines, which is basically where lines all kind of, where you got a number of lines that all kind of go through one single point. Okay, and this can be particularly useful, well, this formula that I'm about to show you can be particularly useful for finding the equation of a line that passes through the point of intersection between two other lines without actually having to find that point of intersection. Okay, so this is the way it works, where you've got two lines that share a point of intersection. Any other line sharing the same point of intersection must satisfy the equation L1, which is the equation of the first line, plus some multiple of the second line added to it, right? And where k, which is that multiple number, is some constant, whether it's a whole number, a rational number, or whatever, okay? So the way that it works is consider that L1 is equal to A1x plus B1y plus C equals to 0. This is the general form of that first line. And the second line will be some general form of the second line. So this is an L1 and this is an L2 in cursive. It's not an E. So this is A2x plus B2y plus C2 equals 0. So what it will be would be the equation for L1 plus some number multiplied by the equation for line 2. Does that make sense? Alright. And so that can give us all sorts of lines, so I'm going to use my rule, that can give us all sorts of lines that pass through that same point, right? But we don't actually need to find that point. So any sort of line that passes through that point of intersection without actually having to find that point. Okay, good. So let's have a look at a question that we might see that might be a typical type of question that's kind of on this topic. So it says find the equation of the line passing through 4 minus 2 as well as the point of intersection of this line and this line, alright, and I should say in brackets without finding the point of intersection. So we're going to do that without finding the point of intersection. So the line passing through 4 minus 2 will take the form L1 plus K L2 equals to 0. So it'll be, so it'll be some multiple of the second line added to the first line. Okay. So what we have here is it's going to be equal to 4x plus 2y plus 2 plus k lots of 3x plus 5y minus 9 equals to 0. So what we've got to find is this value of k, and we do that by substituting 4, 2 in, right? So we substitute 4, 2 in. So 4 gives you 4 lots of 4 plus 2 lots of minus 2 plus 2 plus k lots of 3 times 4 plus 5 lots of negative 2 minus 9 equals to 0. Yes? This we work out 16 minus 4 plus 2 plus k lots of, this we work out 12 minus 10 minus 9 equals to 0. This will equal to 14 plus k, how many lots of k? So 12 minus 10 is 2, minus 7 k equals to 0. Which means 14 is equal to 7k, k is equal to 2. Does that make sense? Okay. So once we've worked out that k is equal to 2, it's really simple. We know that the line that passes through 4 and minus 2, also passing through the point of intersection of these two, will be the equation of this line where we substitute 2 for k. Okay? So in other words, the equation of the line will be L1 plus 2 lots of L2 equals to 0. Yes? So in other words, it's 4x plus 2y plus 2 plus 2 lots of 3x plus 5y minus 9 equals to 0. Now, add those two together. So we got 4x plus 2y plus 2 plus 6x plus 10y minus 18, all equaling 0. Add that together, that gives you 10x plus 12y minus 16 equals to 0. So we know that that is the equation of the line that passes through 4, 2, as well as the point of intersection between those two lines. Okay. Now if we look at this line, we can see that it's not in the simplest whole number ratio. So to put it in general form, let's put it in the simplest whole number ratio, and we do that by dividing by 2. Okay, because 2 goes into 10, 2 goes into 12, 2 goes into 16. So divide all sides by 2 and you get 5x plus 6y minus 8 equals to 0. Got it? Alright, so that is how we do these sort of questions that involve concurrent lines. Of course, there is another way of doing it, and that involves probably the long way, and that involves finding the point of intersection between L1 and L2, these two lines, either by substitution or by elimination, and then using the 2-point form between the point of intersection here and this point here to find the equation of the third line. Okay? You could do that, but I often find that this way is a lot more simpler. Thank you very much for watching.